we're going to graph quadratic functions. Quadratic functions have three terms, have three forms. One is called, let me type in here. So standard form, f of x equals to ax squared plus bx plus constant c, called standard form. Then we have another one called vertex form. F of x equals to a times a perfect square, h squared plus k. Another form is called a factored form. F of x equals to some coefficient, leading coefficient, x minus s and x minus t. So those three forms, each one has some advantages. Okay, the first one, let me change my color. The first one, this C tells us y-intercept. So in standard form, the y-intercept, we can see right away, 0, c. So y-intercept. Versus the factored form, we see our x-intercepts right away, which we have s comma 0 and t comma 0. Okay, so standard form give us the y-intercept. Oops. And the factored form give us two x-intercepts. And what does the vertex give us? This h comma k is the vertex. That's why it's called a vertex form. H comma k is the vertex. All right, let's see this one, A. We have in a vertex form, right? So A is -1. Let's write down the information we know. A equals to -1. Now what else do we know? We know h comma k, right? We know the vertex. Vertex h is -2 because in the vertex form we have x minus h. So this is x minus -2. X value is -2. K plus k, in this case plus -3. So our vertex is -2, -3. So we have these two pieces of information. The first piece of information, A equals to -1, tells us this graph is a downward parabola. Okay, so this is called a leading coefficient. If it's negative, it's a downward parabola. If it's positive, it's upward parabola. A vertex, let's draw the vertex. So -2, -3. So the vertex is here. If vertex is here, that means the line of symmetry is here. So this is a line of symmetry, which is go through this point. And this line is called x equals to -2. And we call line of symmetry. Because the quadratic function, the graph of quadratic function is symmetric with this line of symmetry. Symmetry means if I fold the left side to the right-hand side, they overlap. All right, so we have vertex, we have the line of symmetry. We just need to get one more point. Let's get an easy point. Maybe f of, let's see, -1. Right? Or maybe even f of 0. Let's do f of 0, which is a y-intercept. Right? Let's do y-intercept equals to y-intercept in vertex form is not obvious, but let's calculate. So we have 0 plus, let's plug in 0 plus 2 square minus 3. And if we calculate, what do we have? 0 plus 2 is 2. 2 squared is 4, but we have negative sign before. So negative 4 minus 3, that's negative 7. Negative 7. So our y-intercept is 0, comma, negative 7. This is our y-intercept. Now let's draw this point. Right. So 0 on y-axis, negative 7 is here. And we know our parabola is downward because the leading coefficient equals negative. So I'm going to draw this smoothly, like a curvy, not a straight lines. Okay. I keep that, give an arrow to indicate that this graph keeps going down forever, but it's just off my chart. Right? Because x equals negative 2 is a line of symmetry. So these 2 units, that means I have to have another point here because the graph is symmetric. So I'm going to do the same thing, try my best to make a smooth, make a roundish, not a straight line. So this is a graph of this function. Okay, I only need 3 points. I need the vertex. I need the other 2 points. You know, actually I only need 2 points. If I have a vertex, I only need 1 more point. Then use the symmetric property. So this is the first one. Now let's see B. B will have a standard form. So in B, we have standard form. We're able to tell y-intercept right away. What's our y-intercept? 0, 2, right? Y-intercept. Because that comes from this is constant value 2. Then we need, let's figure out the vertex. If we want to figure out the vertex, we need to figure out line of symmetry, right? So line of symmetry. Oops. So we should have this equation, x equals to negative b over 2a. Negative b divided by 2a. Okay, in our case, what's our negative b? Negative 2. Negative 2 become positive 2. Divided by 2 times a. Well, a is just 1. 2 times 1 is 2. So our line of symmetry is 1. So we want to draw the graph of x equals to 1. X equals 1 is here. So we draw a line, a vertical line of x equals to 1. So this is our line of symmetry. And the name is x equals to 1. Right? Because on this line, every x value, every point has a value of x to be 1. Then I know the vertex is on this line. That means the vertex has x value to be 1. I just have to evaluate f of 1. F of 1 equals 1 squared, which is 1, minus 2 times 1 is minus 2, then plus 2. Also, I get 1. So 1, 1 is my vertex. 1, 1, and it's my vertex. Now I can graph my vertex. So 1, 1, right here. Right, 1, 1. Now, what's my A? A, B, C. A is the value before x squared, which is 1, which is positive. Right, it's greater than 0, positive. That means my graph goes upward. That means my graph goes this way. And I have my y-intercept. Let's graph my y-intercept. It's right here. So I know this graph goes this way, this half. By symmetry, I have a point here. Right? I graph this. That's it. I try my best to make this smooth, like a curvish, not a straight line. So that's for B. Let's see C. C is in standard form, right? If it's a standard form, we can tell y-intercept right away. Y-intercept is 0, comma, -4. And the A is being positive. Again, A equals to 1, positive. So we know our graph go upwards. So let's first graph our y-intercept is 0, -4. So we have our y-intercept here. Right? Then let's figure out our line of symmetry. X equals to -b over 2a. In our case, what's our b? B is 0. So x value is 0. Then what's f of 0? F of 0 equals to -4. It's the same, oops. It's the same as our y-intercept. What does that say? That is to say this y-intercept is indeed the vertex. Is indeed the vertex. Because y-axis is the line x equals 0. That's our line of symmetry. Line of symmetry. With x equals 0, which is y-axis. Which is y-axis. All right. So we just need one more point. One more point. Why don't we evaluate f of 1? So I have a, I'm free to pick any x value to evaluate to get the corresponding y value. 1 squared is 1, -4, you get -3. Right? So I get one more point. And this point is x value is 1, y value is -3. So let's graph this point. 1 and -3 right here. By symmetry, I know I have another point here. So now I can graph. If I want to be more precise, actually, we see this x minus 2, x plus 2 give us 2 x-intercepts. So 2 and -2. So if we want to graph more, we're going to graph like this. All right? So how do we find the x-intercept? Let me write on this side. X-intercept. X-intercept means the y value is 0, right? We don't know x value, but the y value is 0. Which in our case is x squared -4 is 0. Remember y is f of x. And that means x squared equals to 4. We square root both sides. We get a 2 and -2. So we get a 2. So our x-intercept is 2, 0 and -2, 0. Right? So we graph with 5 points. That means our graph is even more precise.